refractive index, let it be mu, surrounding, let it be A. We have to use lens maker formula to calculate the focal length. So let me assume a ray of light and it will converge at this particular point. This should be the focus. And whenever we'll call focus, it is a second principal focus only. The radius of curvature, this be R1, R2. Center of curvature of this will be C1, this will be C2. According to lens maker formula, we have like this, no? Mu2 by mu1 minus 1, 1 by R1. Minus 1 by R2. This mu2 is mu and mu1 is 1. So what is the focal length? Will be mu by 1 into radius of curvature of this. Let R1, let this be equal to R1 equal to say R 2R, anything, let it be equal to R magnitude. So substitute now with sign. R1 will be plus R. R1 will be plus R. What about R2? R2 will be negative because how you measure the radius? Because here R1 you're going to measure in the direction of incident ray, whereas R2 you're going to measure opposite incident ray. So therefore this will become minus R. So this will become 1 by F equal to mu minus 1 equal to 2 by R, or F equal to R by 2 mu minus 1. This will call equiconvex lens. Okay, equiconvex lens. There's a special thing. Convex lens only we have brought equiconvex. Next, if the surfaces, radii of the surfaces are not equal, then what has to be done? Why did it not come? Oh, I'll do one thing. A second type of, in this one only, convex lens only. It is not an equiconvex. Not an equiconvex means the ray after refraction, the radii of this be R, let this be 2R. This is the incident ray, refractive index be mu, that of surrounding, let it be A. So this will be the focal length. Then this is not an equiconvex lens now. Now just you can say like a convex lens, what we can call this is. How to calculate focal length? This will be mu plus R minus of minus 2R. Why it should be like a, because the ray, what is R1? The incident ray on the surface first on first surface on which it strikes. The incident ray will strike first this surface, no? So therefore this has to be taken, the radii of curvature of this has to be taken R1. Then the emergent ray will come from the second surface, that has to be taken as R2. Why negative sign? Because this 2R, the center of curvature, this will be here, no? Center of curvature of this one. So you are going to measure this as 2R, no? Whereas this is R. And how you measure R? In the direction of incident ray. 2R opposite incident ray. So therefore this will become okay, this will be 3 by 2R, or F equal to 2R by 3 mu minus 1. This is a convex lens. That was the equiconvex. If both the radii are equal, then it is called like a equiconvex. Okay, fine. This here radii are different. R1 is how much? I should put mod for this, huh? Not for. Okay, there's a converging lens. So like this, we can find out the focal length. So physically, it will be like a bulged disc. You can call this like a bulged disc, that one. So if you see the side view, it will appear like this. That's why in the books we prefer this particular diagram. It will have the radius, this one. Okay, this is about the convex lens.